Okay, so what they want us to do is write the expression in factored form for the area of the shaded region. Now you got a better picture of it in your book on page 198. But if you look at that yellow part, you think about it, isn't that, if I want to find the area of the shaded region, what I could do here, it's like there was a square there, and I'll show you why I know it's a square in a minute, even though they don't tell us it is. It's the area of that square, and it's like somebody took a cookie cutter and cut a circle out of the middle of it. Isn't that how you could look at it? So what we could do is we could, yeah, sounds like a good cookie cutters sound nice. So we're going to subtract the area of that circle. Okay. So they want us just to write an expression, they say, in factored form. So we're going to have to see what that means here. Maybe something we're going to have to do to clean it up here. Now, if you have a circle and it has a radius and they call it R, if I'm trying to find the area of that squared, couldn't I draw a radius from here to here, and wouldn't that be R? Okay. And I could draw another one from up here to here, and wouldn't that also be R, even though my drawing's pretty crummy? So do you agree with me that that square is like R plus R tall?
Yes.
So wouldn't the side of the square be 2R? R plus R is 2R? What about the base of it? Let's say they didn't tell me it was a square. The reason I know it is because I could also draw, let me draw a radius in green now. Isn't from here to here R? Okay. And then from here to here is R, because the radius of a circle, they're equal everywhere. So isn't this base also 2R? So now, if I want the area of the squared, I could use length times width, because a square is a rectangle, but isn't it also the same thing as saying 2R squared, one side squared is how you find the area of a square? Okay, so that right there, that green 2R, the whole thing squared, is the area of my square, but I need to subtract out of it the area of a circle. Do y'all remember anything about the area of a circle, the formula for it?
Pi r squared.
Yeah, pi r squared. Okay, so pi r squared, and our radius here is R, so I don't even have to change that, do I? Now, why did they say they want it in factored form? They want me to divide out anything that those terms have in common. Before I do that, let me simplify. Doesn't 2R squared, couldn't I write that a different way? What is 2 squared? 4, and then R squared would be R squared, right? Now, this is normally how this whole section that we're doing here, this 5.3, it's like dividing out stuff. Is there something I could divide out of both of those terms? Do they have something in common, a greatest common factor? They both have a R squared in them. Good. So the thing they have in common, the GCF here, the greatest common factor, is an R squared. It's the biggest thing I can divide out of both of those terms. I'll give you a minute. See, a lot of you are writing, so I want to give you a minute just so you can kind of get caught up and think. So give you a minute to get caught up. Oh, I can tell I can divide R squared out of both terms. If I have 4R squared and I divide the R squared out, what would be left? The 4. Now, I'm going to copy down that subtraction sign. If I have pi R squared and I divide out the R squared, what would be left? Pi. This is your answer in factored form. You take out the GCF and you write your leftovers in parentheses there. Each of these circles has a radius of R. Here's what I'm going to do. I'm going to draw them differently than the book does, because I need to find out the dimensions of that square. That's a radius of the circle, so they label it R. Couldn't I draw another one to the other side of the circle and say that's R? But now I got another circle, and all these circles have the same radius. So if I drew it from the center to there, that would be R. And if I drew it from the center to the other side of the circle, that would be R. Sounds like pirates here. R, 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 R. If I add all those R's together, how far, what is this direction here? This dimension this way of this square? What is it? It would, okay, our width. What would our width, usually they call this the length. It doesn't really matter because I can rotate the figure and it becomes the width. The dimension going across here, the way I drew those lines, it's R plus R plus R plus R, which would be, Well, no, if I multiplied it, it would be r to the fourth power, but I'm just adding up little segments that are r, right? So it's going to be 4r. Just get it to right, it'd be great. Couldn't I do the same thing the other direction? I'll do it with green. Now again, these are supposed to be touching the side, and my drawing here is hard. I'm holding the iPad in my hand, so it's kind of hard to do that when it's not on a surface. That would be r. From here to here would be another r. If I go to the center of this circle, there's another r. And then from the center to the top is another r. Isn't that 4 r's added together also? So wouldn't this width over here be 4r? Okay, now, they want us to find the area of the shaded region. This is a real typical kind of problem, and a lot of times in geometry, you spend a lot of time doing this. It's just that our geometry book doesn't have you do it, so it kind of ends up happening here in algebra. If you look at what's shaded, it's like it was that whole square, and they cut out 4 identical circles from it. And the circles have been helpful so far because they actually told me how big the dimensions were. I'm just going to try to scribble in this as I'm talking. Do y'all agree with me that the area that's shaded in there is just the area of the square? What am I going to subtract from it, though? 4 circles, right? So I'm going to subtract the area of 4 circles. Okay. What would the area of that square be? What's its dimensions? Yeah, it was the 4 r's that we found. So I could either square 4r or I could say 4r times 4r, because it is a rectangle, so I could say length times width. What would that be, 4r times 4r? 16r. Yeah, 16r squared, right? But now I got to subtract out 4 circles. What's the area of one circle? Well, remember, what's the formula for the area of a circle? Let's pi r squared, right? And we don't know what our number is. But our radius is r, so we just need to write that formula in there, pi r squared. So what I have here is 16r squared minus 4 pi r squared when I multiply all that together. Now, they want it in factored form, which means they want me to divide out anything that's in both terms. What could I divide out here?
4 and r squared.
Yeah, there's a 4 that comes out of the numbers, and then both of them have an r squared. This is my GCF, and what I'm going to put in parentheses are my leftovers. Notice, it is very important to write your GCF out front. Some people divide it out and go, ooh, divide it out, it's gone, and it disappears. You can't do that. That's a very common mistake that I've seen over the years with students. They think they just get to throw it away when they divide it out. But remember, what we write here has to be equal to what was above it, so we can't just go toss it out the window. Okay, so 16r squared. If I divide the 4 out of 16, what's left over? I'm just doing the number part 4 first. 16 divided by 4, looking at this 4, okay, and then I divided the r squared out, so there's nothing else left there, right? Now I'm going to copy down my subtraction sign. I have 4 pi r squared divided by 4r squared. 4 divided by 4 is 1. I could write it down if there's nothing else, but I'll go ahead and write it down. The pi is still in there, right? We didn't divide the pi out. What about the r squareds? They're all gone, right? Yeah. So 1 times pi, do y'all agree with me? That's just pi. Yeah. So my answer would be, in factored form, 4r squared times 4 minus pi. Solve this problem? If they